Tapi ngomongnya tetap kita mampu. Kita mampu ini adalah seorang ibu dengan penuh perjuangan yang tidak pernah menyerah. Dia bahkan memang berjualan kita dan saat ini memang dia tuh sudah berjual karena dia pengen mengganti dengan interior yang baru. Sekarang kan rumah baru, doa baru, harapan baru. Anaknya 6 loh, Bang.
Iya betul. Cuma kan kalau emang kira-kira pengen mengisi tempat baru dengan barang-barang baru.
Coba yang konvensional jadi jualnya buat campur gitu.
Mas, suaranya mas masuk. Assalamualaikum.
Hello everyone.
Assalamualaikum. Dr. Abdullah.
Good afternoon, everyone.
Selamat siang.
Selamat siang.
Yang Hardi.
Ya.
Waalaikumsalam Pak Hardi.
Ya.
Mas Taikuni udah siap, Mas?
Ya, sudah Mas, siap. Ya, terima kasih.
Ini Mr. Bill udah datang, kemudian Pak
Dr. Abdullah juga sudah.
Abdullah sudah. Pak Asep ini saya nggak tahu, Pak Asep pakai nama yang di Topat atau?
Ada di Topat.
Oh, di Topat ya, Pak?
Ya.
Oh, oke. Sudah lengkap.
Selamat siang Pak Toto. Lapor.
Oh iya, selamat siang Pak Bambang.
Pak Hardi.
Selamat siang.
Sehat
siang Bu Eni.
Bu Eni.
Ya, Pak Kendra.
Selamat siang Prof. Bakuni.
Ya, selamat siang. Apa
Pak
kabar?
Bakuni, Prof.
Ya.
Selamat siang Pak Hardi.
Selamat siang. Wah, Pak Kendra itu gimana kabarnya Pak Kendra?
Alhamdulillah Pak, sehat. Bapak juga sehat terus ya.
Alhamdulillah.
Luar biasa Pak Hardi. Semangatnya.
Ya, sisa-sisa semangat, sisa-sisanya. Mas Bambang Sabto.
Selamat siang, Bapak.
Selamat siang, Pak Bambang.
Reuni ini sampai Surabaya juga Pak Bangun ada.
Ya. Nih, gimana Mas Bambang?
Alhamdulillah.
Nah, Mas Bangun.
Ya.
Pak Bangun.
Nih,
Nembi
mohon
bangun.
maaf. Nanti saya itu
Mr. Wake
lebih
up.
cepat meninggalkan Pak, karena ada juga kegiatan sama, ya.
Oh, ada.
Jadi ada kegiatan yang sama-sama webinar.
iya.
Jadi nanti jam 3 gitu. Ya. Nggak bisa ikutin. Jadi pagi-pagi. Halo, Pak Kendra, gimana?
Halo, siap Pak Bangun.
Ganteng aja.
Aduh, Pak Bangun
Ganteng aja.
siap-siap.
Matur nuwun, itu bukunya.
Menurun.
Bukunya.
Bukunya Pak Kendra itu macam-macam itu zaman dulu saya
Ya.
banyak itu dapat buku.
Iya.
Buku-buku.
Iseng Pak, iseng.
Buku-buku hiburan.
Terima kasih.
Iseng.
Saya selalu mengalir Pak Kendra.
Mulai dari referensi sampai ke komik sampai ke
Dr. Abdullah, how are you?
Hello, how is everybody today?
Oh, fine, just fine.
Thank you for the opportunity to meet your team.
Yeah, we are eager to know more about what you are developing there.
Absolutely. We're very excited. There's many projects that we've done in some of the neighboring countries. So we're looking forward to showing you several examples and giving you a background of what we developed here.
Pak Toto, selamat siang.
Siang, Pak.
Pas seger Pak Toto, kelihatan seger.
Seger.
Maksudnya habis mandi gitu, Pak.
belum ada jawaban lagi ya Pak ya. Dari
Tutu ngono tok.
ini belum ada jawaban Pak Toto.
Tadi nggak mandi tadi.
Kenapa, Pak?
Berarti tadi nggak mandi, kan baru mandi sekarang.
Belum ada jawaban.
Iya, Pak Hardi. Bentar, ini ada yang tanya, nggak ada jawaban Pak. Pak Bangun.
Pak Bangun.
Iya. Belum, Pak. Belum
ya Pak ya. Iya.
Itu Bu Heni mintanya setelah hari ini, Pak.
Iya.
Bu Heni
harus ini ya, apa namanya, ngantri kayaknya.
Ya. Pak Baiku ini udah jam 2
lebih.
Ya, mungkin mulai aja, Pak.
Oke, ya saya pembicaranya sudah hadir.
Iya, udah lengkap ya. Ini saya bawa mahasiswa saya.
Oh iya, bagus lah.
Supaya ada wawasan, Pak Hardi.
Benar sekali. Kita harus rajin melihat keluar. Kita jangan terkungkung dia kita sendiri.
Iya.
Cepat, perkembangan cepat sekali. Very fast.
Jadi saya coba ini, mereka saya kasih soal, saya kasih tugas kira-kira bagaimana analisa ketelitian dari masing-masing dokumen, Pak.
Ya, saya kira
Iya.
bisa mengacu pada banyak papers di American Society of Photogrammetry.
Iya, betul. Iya.
Ambil dari situ.
Jadi kalau kita hanya didasarkan teori kan mungkin tidak aplikabel ya. Jadi artinya kalau ada case, ada satu kasus gitu mungkin akan lebih menarik gitu.
Ya, kemudian terapkan di kita.
Iya.
Kita coba. Jadi kita nggak usah baru, kita pakai.
Iya. Karena di kita tuh, di profesi kita tuh tantangan penelitian kan masih banyak, Mas.
Iya.
Iya.
Cuma relatif lambat. Saya mulai fotogrametri di UTM itu tahun 76-79.
Iya.
Doktornya sudah banyak sekali.
Iya.
Seperti Dr. Abdullah ini kan generasi kedua sudah. Dr. Abdullah itu mungkin mahasiswanya murid-murid saya dulu.
Ya Pak Hardi.
Ya, yes.
Assalamualaikum semua.
Waalaikumsalam.
Waalaikumsalam.
Yes. It's glad
Sungguh
to see you.
bangga dapat berdiskusi dengan semua.
Iya.
Yes, yes.
Sekarang udah ganteng lagi Pak, tambah ganteng.
I started 76 photogrammetry in UTM.
Oh, 76.
76, the first batch.
Oh, okay.
Datuk Kadir, Datuk Fauzi was my first.
Okay.
I attended the inauguration, when they finished their study. I was there. So I built the photogrammetric lab.
Okay.
Now, UTM very fast.
Saya itu dulu satu angkatan dengan Ibrahim Yaakob, Pak Hardi.
Oh, Ibrahim Yaakob. Oh, dia sudah arwah.
Iya.
Ya.
Sudah almarhum, iya.
Ya. Saya punya guru.
Oh, iya.
Kalau Datuk Kadir masih aktif ya.
Datuk Kadir retired from Department of Survey dan sekarang dia sebagai juruko belasan.
Juruko Pak Pruning.
Ya. Practice license.
How about
Datuk Kadir, Datuk Fauzi. Fauzi sama juga juruko belasan.
Ya. Oh, good. They have their activity.
Ya.
Mas Bay langsung aja.
Saya masih kontak Dr. Majid.
Dr. Majid.
Ya, saya masih kontak dia.
Oh, okay. Very successful license surveyor.
Yeah, that's. Pak Baikuni.
Ya,
langsung aja Mas Bay.
Kan langsung ya.
Ya, monggo.
Terima kasih semuanya yang saya hormati para senior, para guru dan para pimpinan. Thank you very much for the speakers, Bill Slayton and Dr. Abdullah Hisam. Let me start this webinar related to the topic that's very important today, that we need to use and develop the map with a bigger scale and can cover very detail of the object of the map. So I want to start this. We start with a short praying dengan mengucap Bismillahirrahmanirrahim, dan marilah kita berdoa bersama-sama mengheningkan cipta. Mulai. Amin. Thank you very much. Let's start directly, and we will please to Master Bill Singleton. I want to give a short CV, curriculum vitae. Bill Singleton is the Vice President at Ecopia and has been with the company for 6 years. His main responsibility is engaging with the geospatial analytical partner to find new ways combining vector-based map with alternate base set to help public and private entities for better understanding and improve communities in which they operate. Previously, he spent 5 years working in the enterprise cell at Cisco System Canada, providing data center and voice solution. Following his, he graduated with MBA from IFA School of Business with a focus on entrepreneurship and managing high growth company. Then I will, then the second speaker, Dr. Abdullah Hisam bin Omar. He is a senior lecturer in the Department of Geoinformation and the Real Estate at Universiti Teknologi of Malaysia, where he has been faculty member since the year of 2000. Dr. Hisam completed his PhD at the Universiti Teknologi of Malaysia. His research interests in the area of geometric engineering, survey mapping, as well as geographical information science. With the 17 years, Dr. Abdullah Hisam has extensive survey and mapping experience in cadastre, marine cadastre, geometric, GIS, and other applications, especially in the town planning department of irrigation and drainage and other firms. Then he has experience in many other countries like Malaysia, Brunei, Abu Dhabi, Oman, Makkah Municipality, and Madinah Development Agency in Saudi Arabia and other area. And then we will have two discussions. First is Brigjen Insinyur Asep di Rosidin MDA. Brigjen Asep adalah Direktur Topografi TNI Angkatan Darat, alumni Lemhanas Republik Indonesia Angkatan 45, dan perwira tinggi sekaligus juru runding perbatasan yang tangguh. Diskusan kedua atau pembahas kedua adalah Insinyur Hardi Koesalamwardi MSE. Beliau adalah senior yang sangat luar biasa, anggota Dewan Geospasial Indonesia, perintis remote sensing di Indonesia, dan tadi disampaikan juga banyak menjadi guru di Malaysia dan sudah cucu murid ini barangkali ya yang ada di sini ini. Dan sampai sekarang di usianya yang lebih dari 85 tahun masih sangat bersemangat mendampingi dan berdiskusi secara intensif dengan kalangan muda termasuk Indonesian Mapping Community dan berbagai komunitas pemetaan. Inilah kurikulum vitae, the speaker dan discussion. Let's go to the first speaker, Bill Singleton. Please, time and place yours. It's yours.
Thank you very much for the introduction today. I want to thank everybody today for giving me the opportunity to speak this evening here in Canada. We are very excited to have the opportunity to speak to the entire team and discuss some of these, to discuss all of the success that we have actually been having using our technology. If you just give me 1 second, I'll bring up my presentation. Can everybody see my screen?
Yes. Yes, it's very clear.
Yeah.
Perfect. Thank you very much. So our organization has been in existence for 2013, and we have been using the latest in machine learning and computer vision to be able to extract highly precise digital maps from the latest aerial imagery. The main problem that we wanted to solve was there's so much new imagery coming online every year from many different sources, whether that be from street view, from aerial imagery, from satellite. And we wanted to give our customers, specifically government clients at the federal level all over the world, the ability to be able to use all of this data that's coming in and be able to create the most accurate vector maps possible in the fastest, most cost-efficient way possible, so that they can do the further analysis and understand what's going on in their communities on a year-to-year basis. We've been recognized in the industry from many different kinds of imagery providers at being some of the best at being able to do this. And I'm really looking forward to the opportunity to show you what we have done over that time period. We've been working in the automation space for quite some time, and we have lots of experience being able to do this, as I'll discuss a little bit later in the presentation. So to start today, I'm going to do a quick summary of Ecopia and our process. I'd like to then quickly jump into the many different kinds of government entities and other commercial clients that we have built maps for across the entire world. Our experience gives us a leg up because we have worked in every different kind of environment, extracting many different kinds of features over many different kinds of terrain. And it's allowed us to build up our machine learning catalog of examples that we've used to tens of millions of examples so that we can actually be able to extract information at the most efficient and highest quality level possible. I'll then quickly discuss some of the other clients that we've worked with, but quickly jump in to our advanced land cover solution. So we've started with a couple basic features, and then we've quickly evolved that technology to start to work on many different other kinds of things that governments may require. And then we've continued to expand that data to start working in the 3D space, which is an exciting new development. Using our 2D technology, we are able to actually also provide elevation models across very large areas, and that's where we've been working on recently. The last piece, I'd like to show you a few examples of some of the data that we have developed for organizations like JUPEM. We have been working in Southeast Asia and Oceania now for over 5 or 6 years, whether it's working with a quasi-governmental entity in Australia, working with the government in New Zealand, Philippines, and Malaysia. So I'd love the opportunity to end my presentation today where I can show you some of the work that we've done and with other people on this call, so that we can show you that we have the capability to do what your team may require in the most efficient method possible. Originally, when Ecopia got our start, we were focused on a few specific features, things like building footprints, road networks, and some other natural features. But what we've done over this time is greatly expand what our capabilities are, as I mentioned. And really what our vision is for the future is we will be building a global base map or a global digital twin of the entire world using our imagery partners in all of the countries around the world. And so this is the kind of information that we want to be providing government entities at all levels, whether it's from the federal level right down to local government, and then also supporting other organizations, like I'll mention in a little bit, similar to insurance, where they're looking for rapid change detection in natural disasters or emergency situations, right over to areas like civil engineering and other commercial entities like telecommunication. One of the strengths of our system is that we are image agnostic. We are able to adapt our technology to work on many different kinds of information sources, and then also pair that with other information sets. And that's where governments have been really happy with what we've been able to create. We have partnerships all around the world, and we've specifically, most of our experience has been working with satellite entities and being able to use their imagery and try to improve their accuracy as much as possible while still maintaining the highest level of accuracy in terms of feature recognition and extraction. Some of the other work that we're doing here in North America is using the base maps that we've created and then also pairing it with other information that governments may already have. Some examples of this are for address points and geocodes. And there's other features as well that we have taken from our government partners or customers and been able to merge that with the base maps we create so that you have the most robust or strong map possible. And that we're trying to merge the work that may already have been done by your teams. So we really want to try to take advantage of imagery that you have and other mapping data that you have to try to create the best map possible. So I don't want to get too much into the details of how the system works, but I'm happy to answer any questions that your team might have. Essentially what we are doing is we've created a semi-automated scalable process that uses our own cloud that we have created internally in order to be able to scale our GPU processing to whatever our customers need. And I'll give you a couple of examples of how this process has gotten stronger and more capable over the many different years. But the most important thing that I like to try to bring up is that this is a proprietary system that has been completely built internally. We have been building this since 2013, which was some very early days in using machine learning and computer vision in this new way using GPUs. And we also have a scalable system of QC experts that we can bring up or down based on the requirements of our customer. And that allows us to quickly match the resources that are required from our customer so that we can respond to the largest projects required while still giving you the highest level of accuracy possible. We've been assessed by the US federal government. We've been assessed by Australia, New Zealand, and all of our results are above 95% accurate. And so really what we're trying to do is get the best of both worlds. We want to try to use automation and all of the training sample data we've created as much as possible for all of the different features we've created and automate as much of the process as possible while still always having a very small team of GIS professionals that we can move up and down to ensure that all of the results are at human level quality. We always want our customers to receive a map that's ready for immediate use. And we want to try to reduce the amount required from your teams. Now, when we work with government partners, they may want to add other things to the map, and we're happy to work in those ways with our customer. But really what we would like to do is try to give you as much as possible in the most accurate way possible so that we reduce the amount of drawing work that your team does so that they can focus on the more advanced kind of analysis when using these kind of data sets. So as I mentioned, what this is allowing us to do is really by using the automation as much as possible and then also the human element, we are able to create the highest accuracy maps while still providing that automation experience in terms of speed and cost savings. And one of the advantages of that is once we've created your map, it's very easy for us to go back and do additional change detection on that area. And so that's actually where we started to work in the reinsurance industry and disaster management with some of our customers. Whether you want to keep your map up to date every year or every 2 years, or there's an emergency situation and you need to have an understanding of how your communities have changed in a very short period of time, we can use this technology to evaluate the previous map that we have created so that we can get you that important necessary change detection information in the shortest period possible so that you can get back to assessing how communities have been impacted by a catastrophic event. So this is just a quick list of some of the current customers that we're working with that you might be familiar with. As I mentioned, we've been working with JUPIM for several years now. There's several examples which I'll show you later in the presentation. We've also worked with NAMRIA in the Philippines, also working with the US government, Ordnance Survey, the federal government of Canada, NASA, Australia. Munich Reinsurance is one of the largest reinsurance organizations in the world. And then also doing a lot of work with the World Bank, which I'll talk about a little later in this presentation, to map 51 countries, to map a number of countries across Africa. So I wanted to bring this slide up just to give you a sense of a lot of different entities that are already using our map data. We're actually working in the 3D space with NASA as we speak, which gives a testament to some of the advancements in our technology as we've been in existence. But I did want to just give you a quick example of what we've done in the past. So one of the first projects that we actually had the opportunity to work on was working for PSMA in Australia. This was back in 2016. We were asked to extract every building footprint across 7.5 million square kilometers of ground. And from the results of that, we were able to identify and extract over 16 million buildings. Over 16 million, oh, sorry, I will move this down just so it's not in the way. Over 16 million buildings across the entire country in a 6-month time span. And this was back in 2016. And you'll see over the next few slides how the advancement in the number of features and our output has increased over a few short years. One of the important things that I do like to identify, and this project was specifically from satellite imagery, is that our extraction by using the semi-automated process is still providing you the highest level of precision and accuracy. If anybody is telling you that they are just using completely automation, a pure automation approach, that's always a red flag, because whenever you're using automation, certain features, especially when it comes to remote sensing data from satellite, there tends to be a lot of difficulty. This is actually a photo from one of the competitors that we've actually worked with. And you'll notice here, they're trying to extract building footprints versus our capabilities. And you'll notice that we are able to divide features, even if they're connected, and actually have a much more true view of what these buildings look like in real life. So you're really getting a very sharp look and feel. Our modeling algorithm actually understands that corners of buildings, for the most part, and there's always exceptions to the rule, have perpendicular corners and parallel lines. Now that's not always the case. This goes back to our training sample, especially a lot of the work that we've done in Africa. There's a lot of circular buildings. So it really just shows you how we've worked in many different kinds of different terrain, and our system is able to adapt to all of the different kinds of terrain that we've worked in. The second project that we took on was actually extracting every building footprint across the United States. So you'll notice here, this project also took us 6 months, but
suaranya hilang.
Suaranya hilang ya. Kita nanti
communication clients and also for the government. Sorry, are you able to still see me?
Yeah, now it's okay.
Okay, perfect. Please let me know if it becomes choppy. So we've actually done 3 updates of this area. And so now we have done the same country multiple times. And now after the 2020 example, we actually see 175 million buildings in the area. So it's just a testament to not only being able to extract the information that you need one time, but being able to work with you to update everything on a consistent basis so that you have the latest data possible. So this was one of our more recent projects that we actually completed for the Bill and Melinda Gates Foundation. So we're helping non-governmental organizations create the first base map of Africa. We extracted 416 million buildings, 17 million linear kilometers of roads, and 582 million hectares of forest. And we were able to do that in 8 months. And it was over an area of 24 million square kilometers. And so really what I'd like to try to get across, and you'll see this in some of the upcoming slides, is we have the capability to really do a very dense, large country's worth of data in a very short period of time and get this done within the year if that's something that is required from your team. Actually, we've actually already gone and detected how many buildings are in each of the countries around the world. That's actually one of the first stage of our automation process, is going through a vast amount of data and trying to understand how many features are there before we go into pixel classification and try to actually extract and model the buildings properly. Using our detection algorithm, we've gone through all of Southeast Asia, actually all of the East Coast of Asia and Oceania, to understand how many buildings are in each country. And based on the building size, if you include buildings that are all the buildings or every building above 10 meters or 20 meters, these are actually the numbers that you'll find in each of the countries and each of your neighboring countries. And so really what I would like to show here is that we already know how much work that this is going to be, but we also have the capabilities. If we were to extract every building footprint within Indonesia, we would still be well within being able to do this year, similar to our Africa project, where we were able to do 5 times this in an 8-month period. So it's really a testament to our ability to understand. We know how much work this is, and we are very confident that we can go in and we can provide these kind of data sets to your team. So the next stage of what we've created is our land cover solution. And so really what we wanted to do is to start expanding what we can provide. And I'll show you an example of this with Jupam in a short few minutes. So I'll actually speed through these slides fairly quickly, but really wanted to give you a taste of some of the features that are being requested by some of the government entities that we work with. The first stage is us taking in imagery, whether it's from satellite imagery or aerial imagery, and then creating and then starting to use our detection and modeling algorithms to build our vector map. And you'll see from this example, these are some of the basic features that we've actually created for some large federal clients so far. Obviously, we have discussed buildings and roadways, but we've also started to expand to a number of other features like parking lots, other pavement, if you wanted to do impervious surface analysis, and then other natural features as well. So there's a number of things that we can start to expand or add to the analysis. Some of our customers actually like to understand where all the swimming pools are for some taxation purposes. So there's a number of things that can be included on top of our typical offering. These layers can be merged, like I mentioned, to do something like an impervious surface analysis. This is actually really important for flood analysis, which we've seen with working with the US federal government. They have actually asked us to do a number of different features for the Coastal Change Management Program, which is run by NOAA, the National Oceanic and Atmospheric Administration, so that they can have a better idea of managing all of their coastlines. And then this is just another example of it just zoomed in a little bit more, but you'll see that features are quite sharp and very accurate. But you'll see more of these examples in a few minutes. So one of our newest products that we've actually developed now, and I have a few examples of this, is starting to use stereo imagery, either stereo aerial imagery or cross-track multi-view satellite imagery, raw imagery, in order to create an elevation profile of the features that we're already collecting. Because we can extract data so efficiently, what our team actually does is extract data in the multi-view, in every single view of raw data. And then we are matching all of those data layers by the vertice of each of our vector features. And so it allows us to improve the accuracy of what we're creating. So it improves the horizontal accuracy of the imagery data that we work with. And then it also allows us to improve the vertical accuracy of all of the elevation of all of the vector feature information. And what we are doing is essentially we can build a DSM and DTM, and then use that raster information and combine it with the 2D vector features that have already been created. So really what we're trying to develop is a lower cost method to create highly accurate, very precise vector features, as you can see, where we're actually even collecting the roof detail of all of the features. And then we can also provide things like 3D canopy, so 3D tree canopy coverage, 3D bridges, and other features if that is something that might be of interest to your team. So this is just a quick, I'll run through this as well because I do have a few examples that we can show your team. But essentially what we're doing is creating, we use the multi-view imagery, whether it's stereo imagery or the cross-track satellite. And then we're creating our DSM, which we can then create the DTM from, and then we can mix those data sources together so that you have a highly precise 3D view of the cities in which you're operating. And this is something that maybe this is not something that you require in year one, but this is something that we can absolutely work with your teams towards. And maybe we do two-dimensional features across the country, and then we do 3D features in some of the select cities, and we can continue to expand that as your requirements may be. So I'm going to take a quick pause right there from the PowerPoint and start to shift over to some of the actual demo data, which I'd love for your team to be able to look at. But I did want to just maybe take a quick pause and see if there's any questions before we did get to the demo data. I'd like to be able to show you an example of work in a few different spots across Jupum. And then I'd also like to show you an area of Thailand, and then 2 examples of our 3D work in Ukraine and the Middle East.
You have 5 minutes.
5 minutes, perfect. So I'll be very quick with this last portion. Just give me 1 second. Perfect. Can you still all see my screen?
Yes, clear.
Perfect. So again, just being mindful of time, I understand I only have 5 minutes left. This is actually, I'm going to show you a few different examples of urban areas in Malaysia, and then also suburban and rural versions of Malaysia. I think this is the most important. The first example that I have up is the building road networks that we were creating. There's a lot of flexibility with how we can create the building road networks. In some of these examples, they've asked us to, if there is a median or if it's a highway, they've asked us to separate into 2 separate lines, which is something that can be shown here. And they've also asked us to do center lines for specific parking lots and some driveways, depending on their length. There's a lot of flexibility here. We can change the requirements based on exactly what your team may need. But this is just the road networks, but I'd also like to then bring in the building footprints. And so what you'll see here is, even in situations where we're working with row housing, we're able to make these determinations and to separate buildings properly at scale. And so we're in the process, and we're working with several people on this call, which we'll hear about in a little bit, with working with the Jupum team to continue to build out these kind of data sets across across the rest of the country. And then the last piece, which I'll bring in, is starting to look at all of the other features. If you just give it 1 second. So now we're starting to add in things like bare land, driveways, forest, parking lots, and other pavement and railway lines, to be able to extract everything so that you have vector features that can be where you can run analysis, understand square footage, understand many other features about the built up environment that your teams are going to be working in. So including things like natural features, water features, etc. And just to scale out a little bit, these are just all small samples. It's a very large file, so I've only brought up some smaller, some small examples, but we're happy to provide more information if that's something that your teams are looking for. The next place I'll go to is another urban area. Just being mindful of time because I only have a few more minutes here. But similar to what I'd shown you before, I wanted to give you examples of more row housing, very densely tight-knit areas that we were able to do extraction for, but then also being able to extract features that might be along water lines. And I can turn these features on and off just to give you sort of a sense of the accuracy here. I'd like to go to one last example just for time. Let me see, we'll go to, I want to show the suburban area. I did want to show an area across but you know what I can also do is, if you just give me one moment, I'd like to just play with
Okay, we give 5 minutes more.
Oh, sorry about that. Well, and again, well, what you know,
yeah,
I can just wrap up quickly because again, we can always come back to this in the Q&A piece. The most important thing I'd like your teams to know, because again, I do have, if I can just quickly show one last thing, less than 5 minutes. This is actually a better way for me to show some of the accuracy here because I wanted to make it transparent. Sorry, I just close this down. But the one piece that I would like to show is, if you just give me 1 second. This is an area in Thailand that we had been working on. And then this is actually a 3D example of 3D buildings. And so you'll notice the precision of the work that we're doing. So we're not only extracting the rooftop, but we're also extracting the building footprint and the facade of each building. And each one of these polygons will have a height. Will have a height aspect to them. And you'll see even when things get very, very, when we start to work in very tight areas or there's different shapes, our system is still able to make that extraction. And then in the last example, which I'll show you very quickly, this is another example from the Middle East where we're working in a very dense neighborhood and still able to do 3D extraction. But the best way to show it is just showing you an example of the DSM that we've been able to create in the past. And you'll see here the multi-level buildings that we've built, just to give you a sense of our team's capabilities. But from there, just to, I'll cut it short because I know I'm a little bit over right now. But again, I want to thank you and your team for taking the time to learn a little bit more about our organization. We've been doing automation we've been doing this kind of advanced automation for a very long time. And we have a lot of experience working with many, many different government clients all around the world. And we would love the opportunity to work with you to create the base map that you might require. But thank you very much.
Thank you very much, Phil Singleton. Excellent presentation with the concept and application that's very detailed, and to show that how the technology of the remote sensing, artificial intelligence can work very precisely to get detailed and precise result. Yeah, thank you very much, Bill. And we will go to the next speaker. I realized that in Canada, maybe 11 hours.
It's
Thank you.
It's a beautiful morning today.
3 o'clock in the morning. Yeah.
Yes.
Thank you very much for your effort to do presentation in the early morning.
No,
okay. Yeah. Please take your coffee break for and breakfast. The next, we will invite Dr. Abdullah Hisam. Omar, please, time's yours. Thank you.
Okay, thank you, Mr. Chairman. I will share my slide. Can everybody see my slide?
Yes.
Yes.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Respected Chairman, and to all the Dewan Geospatial Indonesia members, and thank you for Bill Singleton from Ecopia, from Malaysia representative, and to all the audience, thank you for inviting me to give the experience from the few projects that using the combination, a new alternative method, how to speed up, how to produce a rapid topographic map in Malaysia. So my title will be large-scale topographic feature extraction using high-resolution raster image and artificial intelligence method. So the method is the a new way to produce a map, how to speed up the process of the map production. Okay, my content of presentation, I will give the introduction on the brief feature extraction approach, meteorology, and planimetric accuracy and geometry assessment, and concluding remarks. Okay, the idea of the why Department of Survey and Mapping Malaysia try to shift from the manual digitizing to automated. This is due to the mapping policy, map updating policy in Malaysia that require 3 years for urban area and 5 years for rural area. So with that, with the manual digitizing process, they cannot cope with the policy that requires speed, require a new update data. So with that, they try to explore new opportunities or new alternatives method. So from that, the new combination of high resolution imagery and automatic, semi-automated extraction, feature extraction is the best available at this moment. So from that, they embark few projects, which is I'll also involved as a subject matter expert in this project. So from that, they try to find out, is it viable, this alternative method to be applied. So the idea is to shift from manual digitizing to automated vectorization. And the another point is how to cope with the mapping, map updating policy. That's why DUPEM now, I believe in the future, they will embark on this method for the whole nation. So that's for the introduction. Okay, in terms of feature extraction approach, Ecopia also have explained how their techniques, how their methods. So from that, okay, we can see that before this, conventionally, DUPAM or Department of Survey and Mapping use area photo as a source, main source. But due to time-consuming, heavy workforce, so it will incur a lot of costs. That's why they changed to these new sources. For example, which is using satellite imagery. So there are a lot of sources or providers for satellite imagery, high resolution satellite imagery. So the best so far, okay, is a MEXA, from MEXA 0.3 centimeter HD resolution. So how good is the MEXA and how good is the extraction capability? So from that, we can see the feature extraction approach from Ecopia is the best viable method so far. Okay, I also have a few study. I have also conducted few study comparing few imagery, high resolution imagery from other provider and other automated feature extraction provider. So, but at the end, we found out that this method or this combination method is the best available in the market. Okay, from the you can see what the first is to evaluate the source of data. This is what we try to find before we embark on the project. Not me, but Department of Survey and Mapping. Okay, but I also assist them to run the evaluation. So from this, we found out that the best available high resolution imagery is from MEXA, even though we have few provider in the market, but currently MEXA is the best due to the accuracy and the resolution of the image. Okay, as we can see, the specification, these are from data sheet. Okay, we can see without the accuracy is for 30 centimeter HD is 4.2 meter CE90. So this is the best available for imagery or source that can be used in order to come up with 5,000 map scale. Okay, the idea is to come up with 5,000 map scale. So the best accuracy so far is 30 centimeter. Okay, then the we also conducted a few studies on the cell size, pixel size, in order to come up with the project. So we look into the few characteristics of the satellite imagery. Okay, okay, in the slide, as shown in the slide, we can see that at the left side is a 0.3 spatial resolution satellite imagery for Langkawi. Okay, in geocentric date term of Malaysia 2000. RSO. RSO is a projection coordinate for mapping. And we also compare with 0.5 meter spatial resolution of orthophoto captured by Department of Survey and Mapping. So from both input, we know how we come up with this 5,000 map scale. Okay, the methodology, how we come up with the final output, or we come up with the topographic database, 5,000, National Topographic Database, 1 in 5,000 map scale. Okay, Yes, yeah, the source of the input is raster imagery from MEXA 30 centimeter, which is 4.2 meter CE90 accuracy. From that, we can overlay with the GCP. We need to establish the local ground control and checkpoint in order to check the accuracy of the raster image. Okay. Second step, okay, once we check with the GCP, local GCP, then we continue with second rectification process, which is use the local GCP to rectify the imagery. So in this method, in this step, okay, we need to establish a ground control point using GPS or GNSS equipment. Then for the distribution of the GCP, okay, we need 4 or 5 GCP point in 10,000 map scale. Okay, even though the final output is 5,000 map scale, but we use 5 GCP in order to rectify 10,000 map scale, meaning that we need to 5,000 map scale equivalent to 1,000 map scale. So we use 5 in order to improve the second rectification process. Okay, then we get the result. The result from that, okay, we fit to the vector extracted using Ecopia method technique. Okay, we fit to the Ecopia vector will fit to second rectification imagery or rectify imagery. So it will fit to local rectify imagery. From that, we can check the rectification process using RMSE. And from the, as I said, we have 2 types of GCP. One is the ground control point for rectification process. Another one is checkpoint. Okay, why we need checkpoint? Okay, the checkpoint is used to check the the accuracy of the features, of the vector features, okay, from the second local rectified imagery. So that's why from that we know the accuracy, the final accuracy of the vector of the topographic vectors. From that, okay, in Malaysia, okay, we have the standard for topographic database, okay, which is called JUPEM MS1 ISO 1001 2015 Geospatial Data Acquisition System schema. So we need to shoot all the vectors from the Ecopia extracted using Ecopia to comply with the database schema. So there are processes. One is source, second is extraction, GCP, and database. So these are the flow of the methodology what have been conducted in Department of Survey and Malaysia. Okay, the evaluation. Okay, how good is the 1 in 5,000 topography database extracted from raster imagery and Ecopia. Okay, my evaluation is based on ASPRS standards. So if we see that for map scale 1 in 5,000, the source imagery is 40 to 100 centimeter, but we use 30 centimeter. So RMSE mean error is 88.4 centimeter. This is the tolerance. Okay. So from this, I come up with the evaluation. Okay. There are three projects that have been completed in Malaysia in 2009 and 2020. Okay. One is the in Langkawi, 32 tile, 1 in 5,000 map scale, 32 tile. So the average accuracy of the GSP is 1.6 meter. Okay. Okay, another project, okay, in 2020, okay, this is the left table shows that this the GCP, okay, randomly established, okay, in all the areas, okay, based on the original accuracy, meaning that the original accuracy of the 0.3 meter from MEXA, the original, without any local rectification. So meaning that we have the source and we bring the GPS, we check the accuracy. So the accuracy, the average is in 1.5 meter, 1.6 meter. You can see this is the original. Okay, then we use this GCP, okay, to rectify second rectification process, and from that we check with the CP. From, if you see the accuracy of the is below below 1 meter actually. So meaning that the second local rectification process has improved the accuracy of the imagery and vectors. Okay, for rural area, okay, in 2020, there are 212 212 tiles, 1 in 5,000 scale. Okay, we get below 2.4 meter. So this indicates that, okay, indicates that the original MEXA 0.3 meter resolution, okay, is 4.2, but we get maximum is 2.4, meaning that this imagery have complied with the what they have stated in data sets. Then from that, okay, we come up with another project in Penang, covering part of Penang, Pulau Pinang, and part of Kedah. There are 64 tiles. Very crowded area. So we use 42 GCP, okay, to run the second rectification process and 11 CP for checking. So from that, as you can see, the RMSE for Penang area is 0.5 meter for northern component and 1 meter for eastern component. So meaning that for 1 in 5,000 map scale, the allowable tolerance will be less than 2 meter, the position accuracy. But we get 0.5 and 1 meter. So it will give a lot of improvement, and it is comply with the standards. Okay, based on the ASPR, so the RMNC is below 82, 0.882. This is the final result that we get from the testing, evaluation, okay, which is ASPRS, Accuracy Standard for Digital Geospatial Data, stated that tolerance for first-class digital planimetric data, horizontal accuracy, RMSER, is 0.882 for 1 in 5,000 map scale, but we get 0.882 meters, so it below the, still in the tolerance. So meaning that using this new alternative method, okay, it will provide a very good positioning accuracy, and it can be used for speed up the topographic database production. Okay, another evaluation, I just show the output. I think Mr. Bill also take this area. I think this is the output from both from the extraction. Okay, another thing, another element is geometry. Okay, before the first is positional. The second thing is geometry. We can see, we need to know the geometry of the vectors. Okay, in Malaysia, for terrace area, we need individual lots. Meaning that we need individual lots. Okay, other software, they cannot extract individual lot, is only a block, one block. But for 1 in 5,000, the requirement in JUPAM, in Department of Survey and Malaysia, they need individual lot. So this another key element or very important element. So Ecopia successfully extracted all the individual lots. Okay, from these vectors, then we compare with the local rectified imagery. So from here we can see, using zoom level 100 to 150 zoom level, so we get around 40 to 55 centimeter, meaning that almost one pixel error. Okay, so it's accepted, because it's only 30 centimeter to 55 centimeter. So these are for geometry accuracy. Then these are overlay analysis between extracted vector and raster imagery at zoom level 150 to 1 in 400. So with that, meaning that in terms of positional, accuracy and geometry accuracy, okay, the extracted vectors is compliant to the standard.
You have 5
Okay.
minutes left.
Okay. Okay, this slide shows the extraction for road network and building, center line, road center line. Okay, we use the white mark as a reference. So as I said, one pixel. The error is only 1 pixel or 1.5 pixel. Okay, the success story from the Malaysian side of Malaysian experience. Okay, from that we come out with the map template. Okay, all the features, building footprint, transportation, hydrography, data, vegetation, geology, and so on. So until now, okay, we have JUPAM already embarked on the this method. Totally 428 tiles in total, 2,675 square kilometer. Total month is 5 months. It's not only the extraction. Extraction only take 2 weeks. But what we need is to run the local refinement of the vector in order to comply with the standard. So that's why the total month is only 5 months. So my experience with the previous conventional urban map, we call urban map 1 in 5,000 scale. It will take 1 year, 1.5 years in order to come up with this the output. But using this method, only 5 months we can come up with 400,28 tiles. So it's very improved. Eh? Okay, in terms of implementation hierarchy, how we run this project in Malaysia. Okay, Ecopia, Ecopia, they provide high resolution imagery, feature extraction. Local company, what we local company need to do is to run the QC, QC, feature editing, attribution, and local company need to come up with the comply with the standard in the mapping authority, and to come up with the seamless database and produce and come up with the map template. Okay, so meaning that there are combination of workflows from Mexa, Ecopia, and local company. Okay, with that, my concluding remark is this exploratory study aim to explore an alternative method for rapid large-scale topographic feature extraction and topographic database generation and production. Okay, the ability of combination of high-resolution raster imagery and high feature extraction provide exemplary output product. Okay? So this paper serves as basic for the subsequent implementation of suitable method in large-scale topographic map in Malaysia, Italy. Then it will revitalizing the instrument of rapid and updated topographic. So by now, JUPEM, as I know, JUPEM, they adopt this method for future works in Malaysia, in their department. So with that, I will conclude my presentation. Thank you very much. Terima kasih.
Thank you very much, Dr. Abdullah Hisam, for very excellent presentation with the concept, methodology, as well as the case study that encourage us to think and to reflection. Now, the time to case in Indonesia, I will give time for two discussion or apa namanya, dua pembahas ya, discussion. The first is Brigjen Insinyur Asep di Rosidin. Please, time is yours. Barangkali 10-15 menit.
Pak Baikuni,
ya.
Pak Profesor, bisa dengar suara saya?
Bisa, dengar dengan baik. Terima kasih.
Thank you for Mr. Bill for your excellent presentation. Your technology maybe to be alternative to solve our problem to make 5,000 skill map, or we can make 5,000 skill map faster. Mungkin Pak Baikuni, saya bahasa Indonesia saja ya.
Baik.
Jadi tadi Mr. Bill sudah menjelaskan bagaimana mengotomatisasi pembuatan garis atau vektorisasi ya, atau otomatisasi di dalam pendigitan. Ini saya kira suatu hal yang bagus ya dalam rangka akselerasi proses pembuatan peta yang diwacanakan akan dibuat oleh kita semua, oleh dalam tanda kutip oleh DIG ya. Tapi tentunya teknologi ini harus kita teliti kembali, harus kita analisis kembali apakah memang betul-betul nanti hasilnya itu memenuhi apa yang dipersyaratkan dengan spek yang dibuat oleh kita ya. Walaupun Mr. Bill sendiri tadi sudah menjelaskan berbagai uji dan dia sangat yakin bahwa ini adalah merupakan salah satu solusi untuk mempercepat pembuatan peta atau vektorisasi tadi. Kemudian untuk tadi yang disampaikan oleh Mr. Abdullah Hisam, terima kasih Pak Abdullah, presentasinya sangat jelas dan sangat komprehensif, walaupun waktunya singkat ya. Pak Abdullah tadi sudah menjelaskan bagaimana proses pembuatan peta 5.000 ya, skala 5.000, 1:5.000 di Malaysia. Beliau sudah melakukan penelitian dengan hasil-hasil yang menunjukkan bahwa citra satelit resolusi sangat tinggi memungkinkan untuk pembuatan peta skala 1:5.000. Itu hasil penelitian dari Pak Dr. Abdullah tadi. Saya kira ini merupakan informasi yang bagus, yang lebih meyakinkan kita bahwa citra satelit memang bisa menjadi salah satu alternatif dalam pembuatan peta skala 5.000. Dalam hal ini sudah dibuktikan di Malaysia, dan kita tentunya juga tidak bisa menelan mentah-mentah begitu. Kita harus melakukan penelitian. Mungkin teman-teman di ITB, UGM itu bisa melakukan penelitian, atau di PIG sendiri ya, sehingga kalau keputusan ini diambil, nanti outputnya itu betul-betul memenuhi syarat yang kita harapkan. Citra satelit resolusi sangat tinggi sendiri di tempat kami di Angkatan Darat itu kami sudah menggunakan ya, penggunaan salah satunya untuk melakukan revisi peta topografi skala 1:50.000. Tentunya kalau untuk skala banding 1:50.000 kami sudah melakukan penelitian, itu sangat bagus ya, sangat bagus, karena ketelitian dari citra satelit itu sendiri sudah jauh lebih bagus apa yang kita butuhkan untuk merevisi 1:50.000. Kemudian citra satelit resolusi sangat tinggi ini juga di topografi sudah digunakan untuk penggunaan atau digunakan oleh para prajurit dalam melaksanakan operasi militer, digunakan dalam bentuk citra satelitnya itu sendiri yang sudah kita modifikasi dengan sistem koordinat yang berlaku di Angkatan Darat, kemudian dimasukkan ke sistem yang kita create untuk bisa dibuka di daerah operasi, kemudian bisa diaplikasikan di daerah operasi secara offline. Itu sangat bagus sekali. Sangat membantu para prajurit dalam melaksanakan tugas, dalam melakukan orientasi medan, kemudian dalam melakukan hitungan-hitungan, misalkan medan-medan kritis, di kanan ada apa, di kiri ada apa, di depan targetnya berapa jarak lagi, berapa jauh lagi. Itu sangat berguna untuk kepentingan militer, kepentingan aplikasi di Angkatan Darat. Kemudian di topografi sendiri, peta citra satelit resolusi sangat tinggi juga digunakan dalam pembuatan peta-peta skala besar untuk daerah latihan. Walaupun kami kemarin masih bertanya-tanya, ini masuk nggak ketelitiannya gitu ya, karena kami belum melakukan penelitian. Tapi tadi kami melihat dari apa yang disampaikan oleh Pak Dr. Abdullah tadi, saya jadi percaya diri sekarang. Oh, ternyata sudah dilakukan penelitian, ini bisa gitu ya, ini bisa. Mudah-mudahan nanti teman-teman di lembaga-lembaga riset, Universiti melakukan penelitian juga, sehingga kami bisa mengadopsi hasil-hasilnya, sehingga kami sebagai user dari teknologi pemetaan ini bisa mengaplikasikan dengan yakin gitu ya, kalau sudah dilakukan penelitian di negara kita sendiri. Paling tidak dari penjelasan Pak Abdullah Hisam tadi, kita dapat menyimpulkan bahwa citra satelit resolusi sangat tinggi merupakan salah satu alternatif solusi dalam pembuatan peta skala 5000. Atau paling tidak dari hasil penelitian tadi kan itu ada nilai-nilai ketelitiannya, root mean square-nya berapa, ketelitiannya berapa. Paling tidak kita bisa mengklasifikasikan bahwa peta skala 5000 dari citra satelit resolusi sangat tinggi ini bisa digunakan untuk kepentingan apa gitu ya. Mungkin tidak semua pengguna skala 5000 bisa menggunakan citra satelit sebagai resource, sebagai sumber data. Mungkin yang untuk ketelitian yang sangat strict, sangat akurat, mungkin tidak. Tapi untuk kepentingan lain, ini bisa gitu. Paling tidak digeneralisasi, semua harus teliti, padahal kepentingannya tidak seperti itu semua, sehingga bisa menghemat budget atau dana yang dikeluarkan. Saya kira demikian Pak Profesor Baikuni, ulasan dari kami. Sekali lagi terima kasih kepada Mr. Bill maupun Dr. Abdullah yang sudah memberikan presentasi yang begitu jelas. Demikian, wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih, waalaikumsalam. Terima kasih Pak Jenderal Asep, Edi Rosidin yang telah menyampaikan tanggapannya yang luar biasa dan harapannya kita bisa saling bekerja sama baik Indonesia dan Malaysia maupun juga bersama Kanada ataupun negara-negara lain di dalam memahami, memetakan dan mengelola bumi ini ya. Ini bulan April, tanggal 22 April nanti adalah Hari Bumi, maka tepat sekali Dewan Geospasial Indonesia kali ini membuat webinar dan kita betul-betul punya tanggung jawab untuk masa depan anak cucu kita dan inilah saatnya dan bentuknya kita memanfaatkan teknologi citra satelit resolusi tinggi dan juga artificial intelligence untuk bisa memahami dinamika manusia dan lingkungannya, pembangunan dan pelestarian bumi kita. Terima kasih Bapak Jenderal Asep. Kita lanjut ke Bapak Hardi Koesalamwardi yang merupakan juga anggota Dewan Geospasial Indonesia. Saya persilakan Pak Hardi untuk menyampaikan tanggapannya.
Pak Mas Bae, ini Prof itu Pak Hardi masih
di luar.
Di luar itu.
Oh ya, udah.
Masih ada masalah. Mungkin yang lainnya dulu, Pak.
Ya. Baik, because of Master Hardi Salamwardi out of this webinar, let's start with question and answer. Master Bill, Master Sukendra Marta want to ask with the question. Please open Pak Sukendra Marta. Open your mic. Yeah, thank you.
Yes.
Thank you, Pak Baikuni. Thank you, Bill. I think what you are presenting to us is very interesting. I believe that, and the question is, do you have any strategy? Strategy to, based on your experience in other countries, say for example, to map topographic map. What I mean for the whole country, like Indonesia, which very broad country, right? Using the digitally high, what is called?
Resolution.
High resolution, yeah. High resolution satellite data.
Yes. Yes, so I'd say there was 3 pieces because I see some of the questions as well that have come through the chat. Based on our experience, I'd say the biggest challenge, as I mentioned, is the scale of Indonesia. We have already worked and detected how many features would be in the area. That goes back to the table that I showed, showing that there is approximately 82 million buildings of a certain size across all of Indonesia, across all of the different square kilometers. We have already done projects for NGOs. We've worked with the World Bank to create digital maps over, as I mentioned, 400 million buildings within a year, over 24 million square kilometers within that year. So we have a lot of experience working in different kinds of environments. With that project, we were working in areas that were dense forest, urban environments, deserts, lots of different water features. So we have experience working in many different kinds of environments, and we've already worked in areas in Southeast Asia. So in terms of the scale, I don't think that that's a problem whatsoever. The 2 other challenges that I would say that we might run into are either with cloud cover and image availability, and we can work with multi-view images. So we can actually help try to work with different views from past years to try to fill in areas where there might be cloud cover. That's also something that we've done in the past to try to make sure that we have a complete picture when there is cloud issues. And then the last issue that I think has been the biggest challenge is with vegetation. And I'd like to quickly just show you one example, if you just don't mind me sharing my screen one last time. I'm going to go to another project. If you just give me one, I can just share my screen quickly. So using our process, we are actually able to extract buildings that you might not be able to see because of vegetation. So you can see these examples here. And by using the different multi-view images, you'll see that the trees here can actually cover some of the buildings, but that does not affect our building extraction because we can use multi-view. And also our modeling algorithm, once we are converting our pixel classification probability map to the end vector polygon, our system understands when buildings are being cut off by trees. And so we can actually fix these areas before we even have to use manual editing to ensure that we actually capture the full building. So those are the 3 biggest challenges I think we'd run into, and we've had tons of experience working in environments like that in the past.
Thank you.
Thank you very much. You still want to add something, Mr. Bill?
No, that's it. I would say those are the main challenges: is image availability. Sometimes there are vegetation issues, which I think we can work with. And then the last one, the first one I mentioned, is just the scale, how big it is. And we have lots of experience working. We have tons of experience working for big projects over many different countries, doing features in different kinds of whether it's forest, urban, or for forest or cities or rural areas.
Okay, thank you very much. It is very challenging in applying this technology and system in the archipelago country, like Indonesia. small island, coastal.
Yeah, yes, lots of different kinds.
It's quite interesting and challenging for the future.
Yeah.
Mr. Hardi Salamwardi, Koesalamwardi has been here. Now, please, monggo Pak Hardi, silahkan to discuss atau membahas apa yang tadi disampaikan. Dipersilahkan. Ini di tempat kami Jogja lagi thunderstorm dan maybe if I lost the signal, Pak Toto, please to moderate this session ya. Oke, monggo Pak Hardi, silakan.
Pak Hardi, maybe your microphone still. Okay. Thank you,
Yes,
Pak.
okay. Good morning, Bill.
Good morning.
It's morning in Canada.
Yes. Yeah.
Your presentation is excellent for me, and there's something new for us also. I wonder that what is your opinion, at least, by replacing the operation by manually with the automation? Do we still need operators for this kind of activities? This is one question I will raise to you.
So that's a great question. We have customers who have done many different kinds of ways based on our experience. I think that with remote sensing, there's always going to be a place for operators because there is a lot we can do that's very easy, and we should automate as much of that as possible. Because the technology exists to do that. And we have a lot of experience increasing the amount of features that we can add. Now, there's always going to be individuals who might have, so when you speak of automators, there's people who are going to be doing analysis on the map. So obviously very important. And then there's also going to be sometimes you'll have some small situations where having local knowledge is always important because there might be some things that are a little bit, or that might be different based on the different environments that you're in. So I think that what we would like to do is we would like to create a scenario where we are minimizing the amount of manual work that needs to be done. I think that we can do a lot of it and standardize the work very easily. But again, there's always going to be some very small situations where some operators might be assisting, because again, you always want to do your own QC. We can guarantee our results, but you might want to do your own quality assurance, I should say. Be able to go through and check the work.
Okay. It means that actually it is not replacing operators, but to speed up the production. Is it that true like that? To speed up the production. And
so
then,
we actually use our team. We predominantly use automation to speed up the production significantly. Our team and our system has already collected many training samples, tens of millions of training samples based on previous projects that we've worked on. And so our system allows us to get started right away. And we use our small team internally to ensure that all the accuracy is done at the highest level. So we do use I would say people are more important for the checking and making sure accuracy is as high as possible, because working with remote sense data can be difficult in some situations, some edge cases or ambiguous items. And so that's what the people are very important for. But again, the objective is to try to automate as much as possible.
Yeah, okay, I understand that, and then it will be to reduce the operators afraid that they will be replaced by a machine or something like that. But one thing that I am sure that we have to improve, to increase their knowledge, their skill to do this, not replacing, but if they got better training or something like that, do you also put a training program in your activity?
We can discuss that in the future. There's other things that can be added to the map. I know JUPEM, we provide a lot of data for them, and then there is some unique things that they also add. We had the same question, I believe, with their team. I don't think that it's necessarily a fear that operators are replaced, but it makes their life a lot easier. So
yeah. Yes, okay. One thing that I know from Dr. Abdullah presentation that JUPEM using the semi-automation as the not using not fully use the automation, but they mix with the manual also. What is your comment on that?
Okay, Pak Hardi, thank you. Actually, okay, the first question I would like to add something on the workers, the staff, what happened to the existing staff. So okay, maybe in Malay, I will talk in Malay little bit and mix with the English. Okay.
That will be fine. That will be fine.
Okay.
Boleh.
Okay, okay, we in JUPEM, okay, even though we come out this new method, okay, it will speed up the process of generation of topographic database. But in JUPEM, okay, in topography database, we have two components. One is vector, one is attributes. Okay, attributes. Okay, apa yang belum attributes. So the workers still have job to update the attributes because the extraction only extract the vectors.
Yeah.
But okay, for example, Pak Adi, in JUPEM, if they need to come out with the whole measure that consists of 24,000, 1 in 5,000 map scale, 24,000 tiles. One tiles is 2.5 square kilometer. 2.5 times 2.5 kilometer, which is 6.25 square kilometer. So in Malaysia, we have 24,000 tiles. So if we need to update or to come up with a new topography map that based on conventional digitizing, so it will get 100 years.
That's true.
You know, that's true. Yeah, that's why in 5 months, JUPEM have come up with 428 tiles in 5 months only. Okay, I also involved in few project using conventional, 5 project conventional, 5 project for updating urban area map 1 in 5,000. That only for 5 years using manual digitizing, the total number of tiles is 600. 5,000, 5 years. Now we are using this method. Only 5 months we can come up with 428 tiles. So okay, apa yang dibuat when we get the vectors and raster from providers, the local company need to comply with the JUPEM standard. That's why we need to fine tune, clean up, come up with the final seamless database according to JUPEM schema, database schema. Okay, from that, we pass to JUPEM. JUPEM will pass to their fieldwork team. in order to
Yep.
update the attribute.
Yeah,
So,
okay.
meaning that the work is still safe.
Yes,
Don't
yes,
worry.
yes, yes.
Selamat lagi, Pak. Selamat lagi.
Okay, terima kasih. Terima kasih, Doctor.
Terima kasih.
One thing I can ask one thing
Okay.
more to Dr. Abdullah.
Yeah, yeah.
In the paper of the survey department Malaysia, you put mainly the planimetric accuracy test.
Yeah.
How about the vertical data from?
Oh, okay, vertical. Oh.
Yeah.
Okay, because this 2D database.
Yeah, that's right.
That's why we didn't concern on the vertical.
Yeah.
Do
you have any idea what kind of method we can use the 3D the vertical data?
Maybe I think Mr. Billos already presented the method. I think.
Yeah, that's right. The 3 meter, the 3 meter, the accuracy.
Yeah.
Right. Okay. Yes. Okay. Thank you. Thank you.
Ya, terima kasih. Thank you, the great guru Pak Hardi Salamwardi. Terima kasih atas pertanyaan kritis dan discussion-nya. Now it's time for question and answer. I will give opportunity to Gunawan Jaya to open the mic, and you can give question to both of the speaker. Please, Pak Gunawan Jaya. Berikutnya nanti Bapak Putu Gede Nuka Nandaka dari Institut Teknologi 10 November. Two of you, please open the mic and raise your question. Pak Gunawan, silakan.
Udah.
Ya, sudah.
Jadi ini ada dua saya bertanya tadi. Pertama terkait dengan pertanyaan tadi. Ya, adakah contoh pertama, contoh sampel data seperti lokasi yang padat tidak beraturan seperti daerah Jakarta. Itu yang pertama. Terus yang kedua itu data yang digunakan itu ada yang digunakan data maksar yang 0,3 meter. Apakah pernah menggunakan data maksar yang 0,5 meter dan bagaimana hasil akurasi geometrinya? Begitu, Pak.
Okay, I will translate to Mr. Bill. This is the question from Mr. Gunawan. He asking for the example for the slum area or heavy densely populated or building area. Could you have some example for that? And it is possible for application in Jakarta city. The second question related to Pak Abdullah, ya. Mr. Abdullah, if you use the data mixer 0.3 meter, do you have experience using data mixer 0.5 meter and how the accuracy, the geometry related to those two? Okay, please, Bill, you can give some answer to the Mr. Gunawan, please. Make your unmute, please. Yeah.
Sorry about that. Yes, start with the second question first. We have lots of experience working with all of the different Maxar data sets. especially when we work in projects that are all of Africa. There isn't enough 0.3 data in some of those regions, and so we do have to work with 0.5 data in other areas, and we have no problems, and we can maintain all of our accuracy requirements when working with that piece. There are ways, like I mentioned, for us to continue to improve the accuracy before GCP points. We recently did a project in Ukraine, and I can show you, if you just give me 1 second. Share screen.
Yes.
So the first example I'll show is, so this isn't a slum area, but if you just give me 1 moment, let me find a better. So we have done several projects. These are just the examples I have up right now. But working in areas where we have very dense living conditions. We're even able to do 3D extraction in these areas and be able to separate amongst these buildings. So we have many examples of working in very dense areas, and I'm happy to work with the team to provide additional examples of that, especially if you are interested. We can work to build a sample for your team in an area of Indonesia that is of an interest of your team. So yes, we can work with very dense areas. And then the last point that I'll make, we actually just recently, using our multi-level, using the cross-track capabilities, so using multiple vintages of Maxar data, we were able to improve the accuracy of this Ukraine data set before using GCPs. So GCPs would even further increase the accuracy down to a level of, we were assessed by the Ukraine government at 1.67 CE90. And that was the assessment that was done by the government. And if we add GCPs toward that, we even improve the data even more. So there's lots that we can do to work with your team to try to continue to improve the horizontal accuracy of the requirements that you'll have. And I'm always happy to find, if you just give me a moment, I'll see if I can find more dense areas for your team here. These are a lot of tall buildings, but if you just give me 1 moment. So this is, yeah, so just working in a much more densely populated region. And by using the this method, we were able to extract buildings in very, very tight areas. So yes, we do have a lot of experience in very, very dense neighborhoods.
Thank you. Thank you. The second question from Putu Gede Nukanandaka. Please, you can directly to open mic.
Ya, apakah suara saya terdengar?
Ya, silakan.
Is my voice
Kenalkan diri.
clear for the speakers?
Yeah,
okay. Okay, let me introduce myself. My name is Nukanandaka. I'm from Geomatics 10 November Institute Teknologi. I already submit my question in the chat box, so I'll read it again. May I ask how much increase in accuracy in percentage between using Maxar image and the Ecopia semi-AI technology and the conventional way of 3D extraction, like using the other image from other satellite and also using manual digitation? Thank you.
Mr. Abdullah, it's time for you.
Okay. The increasing because in terms of time, is almost 50% increase using this method. In terms of cost, also 40 to 50% increase in decrease in terms of cost. That's why in terms of accuracy, okay, in terms of accuracy, we need to know the scale of the map. It depends on the scale of the map. So the 1 in 5,000, the maximum allowable accuracy for according to JUPAM is around 2.5 meters. So if you can get 1 meter, below 1 meter, as I show in my slide, so is very improved in terms of accuracy. So this method is acceptable. Okay, in terms of if you use 0.5 meter, 0.15 meter, from the data sheet from MEXA is for CE90 is 8.5 meters. So that's why I said if you use 50 centimeter, the accuracy, I assume the accuracy will be 3 meters, something like that. So whether it's suitable for the scale that you are acquired. For me, for JUPAM, they need 1 in 5,000 with accuracy below than 2 meters. So that's why 0.3 meters plus Ecopia method is the best solution available for this at this moment, at this current time. Okay, let me show you example of the sample. Okay, not a sample, this is a real job. Okay, from the project. As you can see, okay, this is a combination of rural or semi-rural area and terrace. So the example of the extraction with this, with the central line, road center line and road edge, this is a requirement from JUPAM. So with that, you see the geometry, we can see the geometry. It's a 90 degrees geometry. So that's why I presented it to accuracy, planimetry, horizontal, positional accuracy and geometry. Based on 1 in 5,000. If you want 1 in 3,000, you need to have very high resolution, or you can use orthophoto, I think, and coming soon, I believe MEXA will come up with 15 centimeter resolution that equivalent to orthophoto. So my answer is depend on map scale. What do you want based on your map scale? So the improvement using this method in terms of production, it will give you 50% to 60% increasing in terms of production, and 40% of decreasing of cost. It saves a lot of cost and it speed up the map production process. Thank you.
Okay, Bill, you want to answer the question, or you want to go to next question?
I think that there's a little bit of dependent on that piece, and there's different resolutions that we've worked on. So similar to the map scale, we've worked with many different kinds of resolutions. So I'll leave that to Dr. Abdullah. But yeah.
Okay, this is another question from Big Winhard Tambu Bolon. Please open the mic, and you can speak directly to Mr. Bill as well as Mr. Abdullah.
Thank you, Mr. Baikuni, for giving me an opportunity to talk. First of all, I want to emphasize and appreciate this presentation, especially from Mr. Bill. It's very interesting, but anyhow, based on my experience and as well as my research, it is still not sufficient to just use the very high resolution satellite imagery without GCP or sufficient DEM. And because our requirement here is, let's say, 1.5 meter circular error 90%, and if anyhow we still use without any GCP based on the literature review as well as the investigation, it is still more than 4 to 5 meters absolute accuracy. We are talking here about the absolute accuracy, not the resolution. And there are two reasons for that. First, we want to ensure that the provided data is synchronized with our Indonesian geospatial reference system. And the second reason is that we need to use the data for the detailed spatial planning purpose. That's why, in my opinion, the GCP and sufficient DM is a must. That's my, let's say, my comment to your presentation. And I want to also get some opinion from your side. Currently, let's say if we want to provide the map or the base map in 1 to 5,000 scale, 1 to 5,000 map scale. The requirement is one, as I mentioned before, 1.5 CE 90%. But in addition, we just also add some requirement for the data sources. In this case, must fulfill half of the intended geometric accuracy. That means the very high resolution satellite imagery must fulfill 0.75 meters. What is your opinion about that, based on your experience and also based on the analytical investigation from the sensor and the platform as well? And for Mr. Abdullah, I also want to compare. What is your opinion about our technical specification, or what is actually your requirement for fulfilling the required accuracy for the JUPAM? Let's say for 1 to 5,000 map scale. What is your requirement actually to fulfill the geometric accuracy of your provided base map? That's all of my questions. I hope it can be heard very good and there is no distortion as well.
Okay, Bill, it's yours.
Yeah, so absolutely, I'd like to go first. So this is actually the example that I wanted to show with the Ukraine data that we were just speaking of. I actually have the Ukraine data pulled up separately. In this particular example, we were working with Ukraine's mapping agency, who has a very high requirement for their absolute horizontal accuracy. And that's where I was mentioning where our accuracy was right by using a DEM, which we can create. We can help create an elevation model along with our 2D extraction. And so without using GCPs, we were at 1.67 meters here. And so we can also add GCPs to that to continue to improve, as we were discussing early on in the presentation, to try to get closer to those requirements. Now, if you see, so this is the actual, the raw data here, or sorry, the base data. But what I would like to show you, if you just give me 1 second. And let me pull up this particular example because I'm showing you some 3D. So this was actually the DSM that we created just using Maxar satellite imagery. And so this is our team using Maxar satellite imagery, creating our elevation. To improve the accuracy of our points. And the way that we're doing this, before GCPs are even included, which will also be provided by the group that we're working with right here. What we're doing is we extract every building and every feature in 4 or 5 different layers of imagery. And then what we do is we match everything together by the vector points. And so what it allows us to do is to continue to improve the absolute accuracy of the features and of the imagery that we're working with. So that's just on our side, but obviously there's other things that would be coming into this. But again, there's other things that we can do to continue to improve accuracy. It depends on what your team requires and the amount of work that you're looking for in order to cover as much scale as possible. I'll pause there.
Let's say for 1.5 meters geometric accuracy.
Well, we would want to include the, as we mentioned, we'd want to include the GCP points on this, on the work that we already did here, in order to continue to drive that to the 1.5 that you might be looking for. But again, that was not something that we included in the JUPEM project, but that's something that we've done. We're working on later.
Okay, thank you, Mr. Bill. Now is Dr. Abdullah.
Okay.
I'm yours.
All right. Okay, in order to answer the question from Mr. Winhart. Okay, at the beginning of my presentation, I come up with the methodology. Okay, the original MEXA 0.3 HD centimeter resolution, CE90 is 4.25. Okay, JUPEM standards for 1 in 5,000, the positional accuracy is 4.25. Okay, when we acquire the MEXA imagery, then we check with the GCP, meaning that we check with the GPS point. We bring the GPS on the ground, check with the images using the features as seen in the image. So bila kita dapat, dan maybe when we get this positional coordinate, then we compare with original coordinate, okay, based on the image. So the original accuracy of the MEXA, even though they claim, okay, MEXA claim put in the data sheet 4.5 CE90, but for most, but we get 2.5 meter without any GCP. So from that, in order to improve the accuracy, because Department of Survey and Mapping needs 1 in 5,000 is below 2.5 meter, even though we have complied with the standard, which is 4.25 meter. Without GCP, meaning that MEXA, we can use MEXA imagery straight, extract, and come up with the map. But due to MEXA, they provide the image in the universal transverse marketer or WGS coordinates. So we need to transform that image to local geocentric data, which is GDM 2000. So from that, we transform all the vectors or the imagery to GDM 2000, to local geocentric formation. From that, we establish a GCP, local GCP. Okay, once we establish local GCP, then we use that local GCP in order to improve from 2.5 to below 1 meter accuracy, geometric accuracy. So that's why the need for local GCP, because okay, in this project, we need local GCP, meaning that we need local team in order to improve the accuracy. So With 0.3, you will get with local GCP, then we will get, that's why we come out, we get below 1 meter accuracy for features. So that's my implementation. Meaning that you need local GCP. But without local GCP, based on JUPAM standard, they on 1 in 5,000 is 4.25 meter for horizontal. So if you want, let's say you don't want to use the local GCP, actually you are already comply with the specification. But as I said, JUPAM needs in local system, local environment. That's why we need to establish GCP in order to improve the positional and feature accuracy. So that's why we get 0.8 meters. It's below 1 meter. So below 1 meter is supposed to be 1 in 3,000 map scales, but the requirement only 1 in 5,000. Maybe that's my answer. Thank you.
Okay, thank you very much, Dr. Abdullah Hisam and Mr. Bill Singleton. I think the time is already over, and I have to conclude that it is very nice discussion and also sharing the knowledge and experience. Thank you from Ecopia, digitalizing the world using artificial intelligence and other technology. It is very important that we have to manage the world with smartness and also wisdom. Also, Mr. Abdullah, Dr. Abdullah, thank you very much for your from Malaysian experience. We can share, and we are eager to cooperate again in the next future. Juga Bapak Jenderal Asep dan segenap sahabat di Top TNI Angkatan Darat, salam hormat dan sukses selalu. Juga Pak guru kita, Bapak Hardi Koesalamwardi, yang luar biasa memberikan selalu semangat untuk diskusi dan memberikan kita semua harapan bahwa kepada yang muda tentu lebih akan menjadi estafet generasi-generasi kita yang ke depan kita berharap akan making the better future using the artificial intelligence, also the remote sensing, and then satellite image, as well as with the wisdom, the local wisdom. We have to promote them because actually the literacy of the people also one of the important thing using technology, and it is more useful and appropriate with human and technology synergy. Thank you very much for all the participant, and especially Pak Toto Sediantoro yang telah memfasilitasi dengan tim Dewan Geospasial Indonesia. Once again, thank you very much. Maybe Pak Toto ada final speak atau penutup, dipersilakan.
Masuk finalnya di saya, Pak.
Itu Pak Toto.
Malah bubar.
Dong. Yang muda itu.
Itu aja Pak Hardi aja, finalnya atas nama DGI, Pak.
Ya.
Pas aku dia wes kok wes.
Ya, terima kasih. Thank you very much for all the participants, speaker, and discussion. Thank you very much. Once again, terima kasih. Salam hormat. Good morning in Canada, and good.
Thank you for all.
Thank you very much.
Okay, then, Bill, good morning.
Iya.
Have a nice breakfast.
Saya close sessionnya ya. Saya close ya.